Welcome everyone. I'd like to introduce Davi Souza. He's with the Federal University of Rio Grande do Norte and also Habitati Mars Analog Station.
Hello everyone, I will start to share my screen now and we start my presentation in just a moment. Jay, if you confirm, if you can see my screen.
Yes, now we can.
Okay, good night from Brazil for all of you that has joined here in this presentation. I'm Davi Souza, as Jay has mentioned. I am from Federal University of Rio Grande do Norte, located here in Brazil. And also I am a researcher at the Mars Analog Station called Habitati Mars, also here in Brazil. And today I'll be presenting about the paper called Proposal of Novel Approach in Deploying Greenhouse Facilities for Life Support and Food Production on Mars. This was a research conducted by me, Davi Souza, Sai from India, that is the coordinator of Habitati Mars, Jess Perwell, and Maria Nassim.
I'm sorry, David, you might have to switch mics, it's echoey.
Sorry, I didn't understand.
You might have joined with the wrong microphone.
I'm with two let me see. Now it's okay.
It sounds very echo. Just check your Zoom settings.
Now you can hear me. Can you hear me?
Your microphone is hot, like it's distorted, like it's picking up too much audio. Maybe try and reduce the volume of your microphone a little bit would help.
I was with the, let me try here again. Could you confirm, Jay, if now it's better?
You have to switch it in Zoom to change microphones.
Just a moment.
Sorry about this.
Now it's better.
Keep going. I think that's better. That sounds better.
Okay. So as I was telling you, this is research conducted by me, Davi Souza, Sai Perrer from India, Professor Julio Rezende, that is the Habitat Mars coordinator, Jas Perwell, and Maria Nassim. And we'll be presenting more topics related to greenhouse facilities for life support and food production on Mars. So some initial considerations about this topic. We're considering the life support system to provide food, air, and water for self-sufficient human presence on settlements on Mars. And we consider some main issues related to water-food nexus in space environments. And it's possible to identify the water limitations that we have, it will happen there. Also some hazards that it will impact on astronaut health. It will be also necessary the construction, the implementation of reliable systems and a sustainable food demand. And when we want to achieve long-term food production on Mars, it will be necessary a high yield and an economic model for crop cultivations and for the whole habitat. And then when we are dealing with this high yield, when we want to achieve an optimal cultivation, it will provide us a creative stimulus with novel combinations of flavor, tastes of food, and also some new textures of the food, of the meals of the astronauts. And when we are considering the logistic of the transportation, it will be also have these two approaches that are the fresh food that we will be producing. It will be necessary to be produced in situ, inside of the habitat, and also some prepackaged meals when we consider this logistic for a long-term presence on Mars, it won't be more feasible because we have a window to arrive on Mars. We need an amount of 6 or to 8 months to arrive there. So as I mentioned, this was a result of international research conducted by the researchers that I've mentioned. And it was research conducted during the virtual analog missions of Habitati Mars. And these missions has appeared due to the COVID-19 situation. And until now, we had an amount of 20 missions realized in the virtual and hybrid methodology. And the idea of these missions is that the participants are challenged to be chiefs of isolated facilities, as you can see here in this picture. This picture shows a design proposed by Yash Hato during the mission 47. And we have not only the greenhouse facility, but we have the main station, the health center, and other facilities related to engineering and launch, and also power generation. And during the mission 42, which has had the participants of this paper, we have focused on food production on a Martian habitat. And for those who are interested in participate, you can contact Professor Julio Rezende, that is the Habitati Mars coordinator, by his email that is here. And also I want to present you a paper overview about the presentation that I and Professor Julio have conducted during the IAC, which finished yesterday. And some results that we have from this research, we are also applying here in our research and in this paper. And we had a lot of results associated to greenhouse building. As you can see in the picture, we have the biohabitat greenhouse, that is the greenhouse of Habitati Mars station. And there we developed some operational protocols and routines to be applied in future space farm environments. So we also had some lessons on system management, maintenance, recycling practice, and food processing, which allowed us to be here, present you another approach for this kind of structures. And we also noticed that the smart agriculture is a potential application to guarantee the confidence related to food production. And we were motivated after this research to look for numeric data on the deployment of greenhouse structures and technologies and other necessary resources, as was presented in the previous by the previous presenter, then topics in his presentation about Grow Mars. I also congratulate him. Some studies in the ISS contributed for the experiments of ISS contributed to look for some challenges on food production. And it's interesting to mention that the most part of the research conducted by inside of the ISS and NASA and other space stations and the space station are related to the how nutritive and how fresh the food is necessary to be cultivated, and also to have a rapid growth, also a high yield productivity, and also related to the resistance and adaptability of the crops. And also I would like to mention here the advanced plant habitat system, which is a closed artificial environment, which motivates us by these goals to provide a nutritional booster of fresh food and physiological benefits for the astronauts in the ISS. And it's also interesting to say that this kind of technology has cameras and is an automated facility and has an amount of 180 sensors inside of this structure. Related to the space greenhouse, we had a lot of insights with this paper, the minimal number of cells for survival on another planet. And I bring here this picture to present you that we have an integration of this of this presented aspect related to energy systems, industrial systems, the living ecosystem, like living organisms, the water, the crops too. And this will be integrated with the building, the greenhouse specifically, when for this presentation. And also we will be integrating in the top of this pyramid, we'll be integrating the human factors. And some technologies associated to the farming environment, we could mention the vertical farming, environmental control by regenerative, renewable energy, artificial lighting, the thermal regulation with heating, ventilation, air conditioning systems, the HVAC systems, also sensory automation, artificial intelligence, machine learning, and many others. And considering the sustainability, the idea of this presentation is to bring a new approach for this kind of structures, and we are mentioning the sustainability. And when we want to consider some interesting aspects, we need also to consider the mission costs. We have a lot of costs related to the transportation and the payload, the supplies, the maintenance of the structures of the rockets, and also the astronaut training. And related to the sustainability, we have these considerations of evolution of lunar base. We have the time of survivability, of sustainability, and the time to be operational. And then when the idea of this evolution is to have in the beginning, we will have more resource transported from Earth with the cargo missions too. And the idea when we achieve an operational structure, we will have a full, we will achieve a self-sufficient habitat and also a greenhouse structure. And some results associated to our research, we need to consider that the greenhouse growth systems will be directly dependent on the infrastructure that we will be deployed in the Mars habitat. And just to present you this schematic, we consider that to transform, to implement, just a moment, to implement a self-sustainable and resilient habitat, it will be also necessary to have a lot of ideas and a lot of solutions related to the controlled environment and agriculture, the CEA. And when we are considering the sustainability, we have two main aspects related to this topic, that is the plant growth and also the circular irrigation. And these both topics are integrated. And related to the plant growth, as we bring here some topics related to greenhouse design, and we will have an amount of interesting rates, of ideal rates, optimal rates related to oxygen generation, the necessary water, and also the volume of the structure to provide the necessary gas exchange inside of the structure. And it will be also necessary related to the plant growth to have the reliable systems to avoid critical situations like losses, emergential situations, fault in the systems, and other things, and also contaminations and other things, many other things that may occur inside of the habitat. And when we consider circular irrigation, we will need to have not only the optimal resource usage, but we need to consider an interesting approach related to the water systems. And with this, we can consider some topics related to wastewater treatment, water management, water analysis, and also and other aspects related to the circulation systems, to recirculating systems, and reuse this and water reusing. And related to the greenhouse design, we can mention that it would be necessary to have some decoupled modules when we want to avoid these critical situations. the best idea is to have this decoupled models in this case, we can isolate the systems and avoid widespread contamination. Also, these systems will be pressurized enclosures, and it will be, as I mentioned, it will be necessary a volume efficiency that we need to have an optimal rate of productivity inside a small structure. A limited structure, and also related to the operational procedures, it will be necessary to be optimal. And the paper about agriculture in Mars presents a lot of aspects related to the protocols associated to associated to space food systems. And our final considerations, as I mentioned, it will be necessary some support technologies for real-time tracking of the plant growth and water distribution to provide relevant information and reports about the systems, the cultivation systems. It will be necessary related to the astronaut training. It will be necessary good instructions and guidelines to help the astronauts on decision support, mainly related to the management of the system, but also we can consider the maintenance and the other routines inside of the greenhouse. And it will be necessary to keep a regular and safe food production with less human interference. That's why it will be necessary many technologies to assist in this kind of activity. Related to the resource life strategies, it will be necessary to have a reduced inputs, such as the biomass, the necessary rate of biomass, and also I can mention the energy supply and other inputs. And also we need to reduce the outputs as the bio-waste and the crop waste, as was mentioned by Dan in his presentation. And the idea of these systems is to achieve an in-situ resource utilization, the ISRU. And when we want to have these strategies for the delivers, we can have some possible deliverables, such as the biomanufacturing, like to produce specific tools and specific materials with the crops, the bioenergy, the biopharma, the use of phytotherapics, and also the biostructures that will be also necessary for these to implement not only the greenhouse, but if necessary, other structures for the whole habitat. And then the idea is to associate these studies related to food production with relevant features on crew performance and astronauts' health and well-being. And when we consider the psychological aspect and also the nutritive aspects of the meals. And these are the reference of this presentation. And thank you very much. This is the Habitati Mars website. We can find us at the YouTube, Twitter, Facebook, and also LinkedIn. And this is the contacts of me, of Sai, and also of Professor Julio. And I'm free for questions now, and thank you very much for the attention.
We have a question about, in the Amazon rainforest, there are many medicinal plants. Do you have any experience with these plants at Habitat Mars?
So Jay, Habitat Mars is located in the northeast Brazil. So we here in the area we have a really dry landscape with other specific crops that it's a kind of different. In Brazil we have the biomas are really different in the regions. So we are just trying to cultivate more leafy greens and other vegetables that are useful and have a lot of nutritional content for our meals during the mission.
Wayne asked about the issue of wind blowing sand that might force the panes of glass, reducing the amount of light that can be transmitted. And what provisions do you have to avoid this type of situation?
Could you repeat the question? I didn't catch the first part.
That winds on Mars could reach 200 miles an hour, and the wind could pick up sand grains, which could force the plane of glass, so that the light transmission would be greatly reduced.
This is a kind of interesting question. As I mentioned in the presentation, the idea of the greenhouse, the space greenhouse, it will be to have an artificial ecosystem. It will be really enclosed, and it will be like more isolated as possible from the surface of Mars. Like it won't have any kind of intervention inside of the structure. But we can also considering some alternative process of lighting that are some research conducted by a professor in US called Bruce Bugby, that his research is looking on fiber optics to have to collect the light from the sun. So in this kind of raining, of dust storms, these systems will be affected. So it will be more feasible to have the LEDs inside of the structures, and we'll be conducting this lighting for the crops.
Pomeo asked, isn't it possible to grow plants without any greenhouse pods or life support systems?
So I never saw any kind of situation like without an artificial ecosystem or a life support system. But the most near aspect related to the environment of Mars that we have associated to the cultivation of crops is the use of the Martian regolith, that are some research conducted by Wade Wemelink, a researcher at Netherlands. But also here in Habitati Mars, we started to implement this kind of research too. We are collecting some basalt rocks, and we are trying to implement a closed environment to see how is the behavior of the development of plants inside of the structures using this analog soil.
Okay, we have a question from another space nut.
Hi there. Regarding the regolith that you intend to use to cultivate crops, how much of an issue are the perchlorates going to be actually on Mars, and is that something you're factoring for in these initial stages of preparation?
So I believe that the first thing it will be to avoid any kind of to have as less ions and compostings inside of the soil of the regolith that may affect on crops, and maybe it could have some studies related to it. But I consider that related to this aspect, it will be necessary to have a better analysis of the soil, of the nutrients, of the composition of the soil, to see if the crops won't be affected by it.
And so is that going to be a factor as part of these sample return missions in the early 2030s? Is that going to be focusing on exploring the true composition of a sample back on Earth for future projects like Habitat Mars?
Yeah, I believe so. Like when, if we consider the Apollo missions, they had bring a lot of samples of the lunar regolith that allowed this kind of research on with the use of lunar soil to produce food.
Brilliant. Thank you very much for your answers today.
You are welcome.
Also, I'd like to complement this area where the Habitati Mars is located. We have a volcano and then a extinct volcano. And then also we found some articles consider the soil based in basalt be used as a knowledge soil. And then we did extravehicular activity in this area of the volcano because it looks like very Mars landscape. And then we collect some soil there. And then in the next missions, we will be cultivating using specific protocols, some kinds of plants in these areas, okay?
Hello.
Hello, Kirag. You can answer. You can ask. Sorry.
Hello.
Yeah, we can hear you.
Go
Hello.
ahead. Okay, Patrick had a question. What do you think would be more suitable for Mars greenhouses? Ad hoc systems or highly modular systems? In other words, which one would be best? A balance between high efficiency but less flexibility, or more flexibility with less efficiency?
So related to the modules, I think it will be necessary to have the coupled structures. I really defend it because in case of any situation of losses, we need to avoid the widespread of the contamination of the contaminants. So if we have any kind of opportunity to save the resource that we have that are still available, it will be necessary. So these kind of modules will be allowing us to have, like, when we deal with during the missions of Habitati Mars, we have the idea to each facility that we presented has a micro food production. So in case of isolation of contamination, the astronauts of other facilities won't be necessary to have the crops to have the delivers from the greenhouse. So it will be necessary this kind of approach. But we can consider too, related to the flexibility and the efficiency of the systems. I believe that it will be necessary to have the most alternative as possible. Like if we have different kinds of cultivating systems like hydroponics, aeroponics, vertical garden, and also like the cultivation of algae, we will have different delivers from different systems. So in any kind of, we have any kind of loss of situation that may occur, it will have the other systems to keep a regular supply of food.
So just to expand on that quickly, sorry, I know I'm taking up a lot of your time. Earlier it was mentioned that winds can pick up quite a lot of Martian regolith and throw that at quite a high speed at any structure. Dust storms are quite common on Mars, and some of those can last up to about 6 months. Is that going to be an issue in sort of light gathering? Are you planning an alternative light source in case of that kind of scenario?
As I mentioned, if we have the most alternative resources and technologies and systems that allowed us to have to avoid this kind of situations, it will be the better. You know, it will be the best. So it will be necessary to integrate not only the sunlight to collect the sunlight, but also to have the LED artificial lighting inside of the structure. In case of any kind of these situations, you know.
Brilliant. Thank you once again for an answer.
Hello.
Hi.
You are welcome.
This is the official
Hello.
end of the session, but we'll leave the room
Thank you
open
all.
another 10 or 15 minutes. So you could continue with
Thank you very much. Thank you for all the questions, and thank you, Jay, for to be here conducting the presentation.
So anyone with questions could just speak up.
Hello.
Hello, Kirag.
Hey, bro. What's up? As you told that you will be directly adding the artificial light on the leaves of the plants. So don't you think it will mutate the DNA of the plant and it may lead to something else like another species or anything?
Could you repeat your question, please? I didn't catch the whole question. I'm
So
sorry.
as you told that you are gonna add artificial lights on the leaves of the plants. So don't you think it may mutate the DNA of the plant leaves?
Let I also try a compliment. I like to comment that the artificial lighting it just used at the International Space Station, and then they are researching about the length of lightning, and also how this is impacted the DNA of plants, and then they also cultivate the different plants, vegetables in International Space Station like lettuce and
Yeah, for now, in the ISS
a
studies,
lot of knowledge
they
about
are.
how they are.
I'm sorry, Professor Julia. Go ahead.
No, you can go. Yeah.
As I
I
was
just finished.
okay, as well as Professor Julia mentioned, in the ISS they are studying more the effects of the environment in the plants, in the genetic of plants, and how it affects in the plant development. We are considering more the structural, like it's before of the crops cultivation. In the case of the artificial lightings, we have a lot of rates of wavelengths that allowed us an optimal crop cultivation, like an optimal photosynthesis of the plants, you know. And then
So as
these
you
are
know
some
that
studies.
human. Sorry, continue.
Go ahead. No, go ahead.
So as you know that human DNA goes with 360 nanometers, and it may absorb maximum at 460 nanometers. So plants, of course, will be needing less than that.
So I believe that if we have associated with this kind of artificial lighting, just considering the artificial lighting, right? So the idea is to provide an environment as much as similar that we have here on Earth. So if it is possible with the technological support, we would like to simulate the daily light, the day and night here on Earth, you know? So we can simulate with different wavelengths of lightning, like the sunlight, and when the sun is go down and when we have the night. So it's possible to have many approaches and many solutions on this specific topic, you know. This is I'm mentioning related to the LEDs, the artificial lighting, but I also mentioned the optical fiber technology that has been conducting, that the Bugby are conducting some studies on it. And if we consider that the fiber optics have, each fiber optic and each material has different wavelengths, and the sunlight has all the wavelengths, we can only isolate the wavelength that we want, and that will be more feasible for the crop cultivation and the crop development, you know.
So as you know, I do pursue biotechnology. So haven't you thought of modifying DNA before cultivating plants to make them resist against many things like that may affect their growth?
Yeah, if we integrate the biotechnology as much possible with the engineering solutions, it will be necessary. As I mentioned, all the alternatives that are available for us are welcome, you know. So the idea is just to keep a regular food production on the Mars habitat, and if we have any kind of solution that allowed us this regular and safe and keep the reliability of the food cultivation systems, this will be the best case.
Thank you.
You are welcome. Thank you for the questions, Kirag.
Oh, you are welcome to India.
So does anyone has another question?
Congratulations, Davi, for the presentation and then discussion. Also, I'd
Thank
like
you very
to
much.
add that we can develop agriculture research in Habitati Mars in Brazil. If you have some researchers here in this audience, if you like to discuss with us some possibility to reply your research in the Habitati Mars Space Analog Station, you are welcome. Okay. Also, I will write in my email here to contact.
And thank you for all those that has congratulated in the chat. Thank you very much. Thank you, Federico. It's a pleasure to be here presenting to you our results and the development of our research in Brazil.
Thank you very much. And I'll end the session now.
Okay, bye everyone.